what's rightfully mine. Take what's rightfully mine. But that aside, you don't know me, you for cuckoo. I say this head bigger than your duku. Stubborn Academy, we like to shoot too.
Hello everyone, welcome to today's class. So today we are going to be looking at question on solution. So this is the question. The vapor pressure of a solution containing 20 grams of a non-volatile solute is 200 grams of water at 27 degrees Celsius is 27.4 ton. So calculate the molar mass of the solute, assuming that the solution behaves ideally. So then the vapor pressure of water at this temperature is given as 28.065 ton. So how do we do this calculation? We are going to be making use of this formula. So this formula is derived from the Raoult's law. So when we derive this formula, we have this. So we need to know what each parameter represents in this equation. So let's start with change in P. Change in P represents the change in the vapor pressure, and P naught represents the vapor pressure of the solvent, so which is P naught, and we also have W2. W2 represents the weight of the solute. W1 represents the weight of the solvent. M1 represents the molar mass of the solvent. M2 represents the molar mass of the solute. So what we are looking for from the question is to calculate the molar mass of the solute. So remember, in a solution, solution is made up of a solute and a solvent. So the combination of solute and solvent gives us the solution. So that means here I will use here to show the solute, and I'll be using 1 to show for the solvent. So whenever you see 1, we are talking about the solvent. Whenever you see 2, we are talking about the solute. M2 is what we are finding. So I will make M2 the subject formula. So M2 will be equal to, if we cross multiply and divide to make M2 the subject formula, what we'll be having is P naught W2 then M1 all over, we have change in P then W1. So with this formula, I will be getting the molar mass of the solute. So now let's know what this M1, M2 is here. M1, W1 and W2 represent. So our M1 is the molar mass of the solvent, which our solvent here is water. So water represents the solvent. So water is given as H2O, so which means we're having 2 of H plus that of oxygen. So if we should substitute their respective masses, we'll be having 2 times 1 plus 16, so which will give us 18. So we have 18 grams per mole for the first one, that is the molar mass of the solvent. Now W1 is the weight of the solvent. So the weight of the solvent here is given in the question. So they say 200 grams of water. So the weight of the solvent is 200 grams. Then we also have W2. W2 is the weight of the solute. So say containing a solute, a non-volatile solute of 20 grams. So we have this as 20 grams. Now we see another parameter that is important to know is the P naught. So we say the P naught is the vapor pressure of the solvent. So the solvents have a vapor pressure of 28.065. So we have 28.065. So we also can find the change of the vapor pressure, which is P naught minus P. So that is the change in the vapor pressure. So if we substitute, we have 28.065 minus the vapor pressure of the solution was given. So they say assuming that the solution behave ideally, and the vapor pressure of the solution is given as 27.4 torr. So this is the P, which is 27.4. So if you subtract these two, this will give us 0.665. So that is the change in the vapor pressure. Now we go back to the formula used for the M2. So we already make M2 the subject formula, so we have this. Now if we should divide P naught is given here from our finding is 28.065, then times W2 is 20 gram, times M1. Our M1 is 18 gram per mole. So we have change in P, which we calculate as 0.665 times W1. Our W1 is 200. So if you should punch this in your calculator, this will give us 75.97 gram per mole. So that gives you the molar mass of the solutes. So this is how we do the calculation for this. So in the next video, we are going to see other relations to calculate for molar mass using boiling point elevation and freezing point depression. So see you in the next video. Thank you.